Commit charge is 100% full, but physical memory is just 60% when using no page file. I have disabled the page file in my system. Hard disk is too slow. Cannot buy a new one right away. Cannot move page file to another partition. When I see into Resource Monitor, using memory-demanding applications, the system shows that commit charge is almost 100% full. Indeed, if I keep on demanding more memory, programs start to crash as commit charge effectively reaches 100%. In the meanwhile, the system says I'm using just 50 to 60% physical memory and have around 1 GB memory available, free plus standby. If commit charge is the total memory actually requested, why does the system says so much memory is free? Is the physical memory being unused by Windows? Is the memory graph wrong? Am I missing something?
Running out of commit limit while you still have lots of available RAM is not at all unusual. Neither the commit limit nor the commit charge are directly related to free or available RAM. The commit limit equals current page file size plus RAM size. Since you have no page file, the commit limit is smaller than it would be if you had a page file. It doesn't matter how much of the RAM is free. For the commit limit, only the amount of RAM installed matters. You can run out of commit limit even with 90% of your RAM free or available. Commit charge is a count of virtual memory, not physical. Suppose my program asks for 2 GB committed, but then it only accesses 0.5 GB of it. The remaining 1.5 GB never gets faulted in, never gets assigned to RAM, so RAM usage does not reflect the 2 GB. Only 0.5 GB. Still, system commit is increased by 2 GB because the system has committed that there will be a place to hold my 2 GB, should I actually need it all. The fact that on any given run of the program I won't necessarily try to use it all doesn't help. I asked for 2 GB and the successful return from that call tells me that the OS committed, i.e. promised, that I can use that much virtual address space. The OS can't make that promise unless there is some place to keep it all. So, put your page file back, add more RAM, or run less stuff at one time. Or some combination of the three. These are your only options for avoiding the low on memory and out of memory errors. See also my answers here, longer, and here, much longer.
As the memory allocation test in the article at this URL illustrates, Windows is a type of system that would fail a large memory allocation if such allocation, together with all the prior allocations, the concept Microsoft calls as commit, would bring the total commit above the sum of both the physical memory and the sum of all the page files, swap. Consider that an allocation by itself doesn't use any actual memory, neither physical nor swap, prior to a read or write taking place within the virtual address space of the process for the aforementioned allocation. For example, a 2 GB allocation by itself would only affect the commit numbers in Windows 7 talk, leaving physical memory alone, until read/write within the set allocation happens. As far as OS design goes, the alternative approach would be to always allow allocation of any size, unless the available memory is already completely exhausted, and then let the applications fail on read/write instead. See this URL for more details.
The available memory is not what you think it would be.
It not unused it really a file cache of recently terminated processes or trimed processes that have been forced to give up some memory to other processes. They could be called back to their original purpose. See for more detail. This URL. As to not have a page file, this is very bad. Windows degrades poorly without one. Remember, even executable files are used as swap files when there is no page file. Even if the drive is slow, it's better to have a page file until you get up to 8 to 16 gigs of memory. Some people think even Windows 7 can run without one then. I regularly give old machine a boost by doing a few things. Clean up the hard drive as much as possible. Copy anything you can temporarily remove from the drive onto a backup. Remove applications you don't need. Remove apps can reinstall. When all that is done, defragment your hard disk. At that point, recreate your page file. It will be the closest to the front of the drive as is possible. Create a fixed size about 1.5 times memory. That's my rule. Usually I have seen sizes between 1 and 3 times memory. This will give it a slight boost in speed over the usual places it would be placed. I use the OSLogic defragger, it's free, ads for more tool though. There are other that do this too. Check out the defraggers at portableops.com. It optimizes the disk by placing recently accessed files near the front of the drive for faster access. It shows where the page file is placed so you can see if you moved it to the top 25% of the drive. After that, reinstall apps and copy back your data. I would say you get 10 or 20% boost. But the main value is a lot of the hesitation goes away for a smoother experience.
If you want to support the channel, please consider subscribing.